So I'm going to talk about one of the properties of exponents, and in this video I'm going to tell you about or demonstrate what it is to multiply when you have common bases. This is the same as saying I've got two x's, so if I say I've got this x squared, this is really xx, and if I say that I've got x to the third, well, this is the same as saying I've got x, x, x. And in the end, I have 5x's, which is the same as saying I have x to the fifth. Well, there's a rule that we can use, and the rule that matches this is that I am taking these powers right here, and I'm adding them, and that ends up giving me this x to the fifth. So I'm going to write that rule down and say, well, if I have x to the 2 plus 3, well, that equals x to the fifth. So I'm adding the exponents. So I add the exponents. So I'm going to use this same rule in rational exponents, and that's what we've been using lately. So if I have something like this, if I have x to the 2/3 times x to the 1/3, well, that's the same as saying I have x to the 2/3 plus 1/3. Well, when I'm adding fractions, my denominator stays the same, and this is the same as saying I have x to the 3/3, and that's just x to the 1. And we know that writing a rational or a fractional exponent is the same as having a radical. So I'm going to rewrite this in radical form and say, well, I know that the denominator, which is on the bottom, is my root. So I have a cubed root of x squared. And then this guy right here is the cubed root of x to the 1. Well, I know that it's got to end up having this answer right here. So I know that when I'm done, that I should have an x to the 1. Because it's the same thing. I've just rearranged the way it looks. So what I'm going to do is, because they have the common index or the common root, I can put them under one radical. And I can say this is x squared times x to the 1. And then I'm back to using the same property where I can add the exponents and say, well, this is the same as saying I have x to the 2 plus 1, and that's the same as x to the third. And these are opposite operations where I can cancel out. So I'm going to say these are opposite operations. And I can cancel those out, and that leaves me just an x. So I can write this down as just x. And this right here, this x to the 1, well, I could have just said, well, that's the same as x. And in the end, I have the same answer either way I do it.